special angles. The special angles we are going to consider are angle 30, angle 45, and angle 60. But let us start with angle 45 degrees. Is that okay? Now, you will agree with me that we said in our previous lecture on trigonometric ratios that before we analyze special angles, we have to make some mathematical assumptions. The mathematical assumptions we will consider in order to analyze the special angle 45 is that the right angle triangle, this right angle triangle over here, whose angle is 45 degrees, the angle here is 45 degrees, whose angle is 45 degrees, with the opposite and the adjacent sides to be equal to 1 unit, will follow the following steps. Now, the opposite side here is 1 and the adjacent side is 1. And let us call this triangle A, B, C. The assumption has already been stated. Is that okay? And we said from our previous class that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. So, what is our hypotenuse here? Let's call this the small letter B, small letter C, and small letter A. So, B squared is equal to A squared plus C squared. If that is the case, then B squared will be equal to 1 squared plus 1 squared. So, B squared is 2. Therefore, B is equal to the square root of 2. So, the hypotenuse side is equal to the square root of 2. Now, to get the corresponding angles for the corresponding trigonometric ratios for the angle 45 degree, we'll consider what we call SOHCAHTOA. And I'm sure you still remember what SOHCAHTOA means. S stands for sine, C stands for cosine, and D stands for tangent. Is that okay? So now let us consider sine 45 degrees. Sine 45 degrees. Of course, sine is opposite over hypotenuse. From so, this O stands for opposite, while H stands for the hypotenuse. So sine 45 degree is opposite, which is 1 over root 2. And by rationalization, if you want to rationalize this, you multiply by the denominator. So this will give us root 2 over root 4, which is equal to root 2 over 2. So that is the special angle sine 45 degrees. You can also do for cos 45 degrees. Cos is adjacent over hypotenuse. So we have our adjacent to be equal to 1 and the hypotenuse is 2, which is also by rationalization equal to root 2 over 2. But the tangent, which is tan 45 degrees, is equal to the opposite all over the adjacent, which is 1 over 1, which is equal to 1. Therefore, the special angle 45 degree follows these processes that we've listed over here. Sin 45 is root 2 over 2, cos 45 is as well root 2 over 2, and tan 45 is equal to 1. So that is for the special angle 45 degrees. We can consider the special angle 30 and 60. And the assumption we are going to consider is an equilateral triangle. This is for special angle 30 degrees and 60 degrees. Like I said, the assumption we're going to consider is the equilateral triangle. And what is an equilateral triangle? An equilateral triangle is, of course, a triangle that consists of equal sides. The sides are equal and the angles here are also equal. So we have angle 60 here, we have angle 60 here, and we have angle 60 degrees here. Of course, the sum of angles in a triangle is equal to 180 degrees. So if this is side A, this is B, and this is C. Therefore, A plus B plus C must be equal to 180 degrees. Is that okay? So this is an equilateral triangle. Now, how do we go about this? We can get a right angle triangle from the equilateral triangle by bisecting this equilateral triangle at the middle. If you bisect it at the middle, we will form two right angle triangles. One to this side and the other to this side. You know, way back while I was younger, we are familiar with this particular right angle triangle facing the right. So most persons thought it was because it was facing the right. That was why they call it the right angle triangle. So one of us, there was a time my teacher asked a student, what type of angle is this one? He said, man, it is a left angle triangle. In fact, I couldn't hold my laughter then. Is that okay? So be it right angle or left angle, the only thing you just need to know is that the right angle triangle is this, and the right angle triangle is also this, okay? So whichever side it is facing, if it's facing your left side, it is still a right angle triangle, insofar as the sum of angles in that particular triangle is equal to 90 degrees. Alright, so coming back to what we have, this side is equal to 30 and this is equal to 30, because if you bring this closer, you realize that 30 plus 30 will give 60 degrees. So this is angle 30 and angle 30. Is that okay? While this is 60 degrees and this is 60 degrees. Now, the assumption that we will consider for the angles 30 and 60 degrees will be that the sides of this triangle has two units. That is, of the equilateral triangle, this is 2, this is 2, and this is 2. So we have 2 over here, we have 2 and 2. That is the assumption. So if we divide 2 into 2 equal halves, we have 1 here, we have 1 here, and 2 would be here, 2 would also be here. So you realize that these two triangles are the same, they are equal. So we can pick one of them and analyze. If we decide to pick the one facing the right, that's the right angle triangle, realize that this, if you are considering angle 30 degrees, so considering angle 30 degrees. For the angle 30 degrees, this becomes the opposite, while this becomes the adjacent. This is the adjacent, and of course, this is the hypotenuse for angle 30 degrees. So, considering angle 30 degrees, we cannot analyze the angle 30 degrees because we don't know the adjacent side, okay? So, we would solve for the adjacent side first before we go over to what we have. Now, if you're solving for the adjacent side, remember that b squared, let us call this as usual a, b, and c. So, b squared equals a squared plus c squared. Of course, this is a, this is b, and this is c. Is that okay? So our b squared is 2 squared, which is equal to 1 squared plus, let's call the adjacent side, let's make it c squared. So this gives 4 equals 1 plus c squared. Having said that, we can continue by collecting the like terms. Of course, c squared will be equal to 4 minus 1, so c squared equals 3. Definitely c equals square root of 3. Is that okay? So this angle c over here will be equal to square root of 3. Square root of 3. Now we can solve for the sine, cosine, and the tangent of 60 and 30 since we have all our sides, since we are given all our sides. Now, this is what we have. So, sine 30 degrees, which is equal to opposite over hypotenuse. And what is our opposite side? Of course, this is 1. We have 1 over hypotenuse is 2. So, sine 30 equals 1 over 2. You can also solve for cos 30 degrees. Cos 30 is adjacent over hypotenuse. Now, adjacent is root 3. So, we have root 3 over 2. Now, the tan 30 degrees is equal to opposite over adjacent. And our opposite is 1, adjacent is root 3. So 1 over root 3 is our tan 30. We can also do the same for sine 60 degrees. In this case, for sine 60 degrees, since this is 60 degrees, this side becomes the opposite, while this side becomes the adjacent, and this other side remains the hypotenuse. Is that okay? So for 60, we use the blue ink, while for 30, we use the green ink. Is that okay? Now, so sine 60 degrees is equal to sine 60 degrees is equal to opposite, of course, over hypotenuse. And what is opposite? Opposite is root 3 over the hypotenuse is 2. So that is the special angle for sine 60 degrees. Now, if you consider for cos 60 degrees will be equal to adjacent over the hypotenuse. And what is our adjacent? Our adjacent in this case is 1. So we have 1 over 2 is our cos 60. Then tan 60 degrees is equal to the opposite side over the adjacent side, which is now equal to root 3 all over 1. Of course, is equal to root 3. So these are the relations or the special angles for the particular cases we have considered. And you will realize that in analysis, sine 30 is equal to cos 60. Are you seeing it? Sine 30 is equal to cos 60. And of course, cos 30 is the same as sine 60. Cos 30 is the same as sine 60. So this is what we have. Now I want you to note that we can also consider this for the inverse trigonometric function, that is for the reciprocal of each of all these functions we've talked about. And to do that, this can also be computed for the inverse trigonometric functions. And I said earlier that, or ratios. And you remember that I said 1 over sine theta is equal to cosec theta. Is that okay? So if sine theta is equal to opposite over hypotenuse, if sine theta is equal to opposite over hypotenuse, therefore 1 over sine theta, which is equal to cosec theta, will be equal to hypotenuse over the opposite side. Is that understood? Now we can do the same for the inverse of cos theta. 1 over cos theta is secant theta or sec theta. And if cos theta is equal to the adjacent over the hypotenuse side, therefore sec theta will be equal to hypotenuse over adjacent. It's that simple. And we can also consider for the cotangent, that's 1 over tan theta equals cot theta. And if tan theta is opposite over adjacent, Therefore, cot theta will be equal to adjacent over opposite. Is that understood? So this is the relation that governs the inverse or the reciprocal of trigonometric functions. Before I wrap it up on this segment, I would like you to compute, just like we did in the previous section, compute sec 60 degrees and sec 30 degrees, compute cosec 60 degrees and cosec 30 degrees, also compute cot 60 degrees and cot 30 degrees. So these will serve as an activity for you, and as soon as you're done, just kindly send your answers to me for review. In our next class, we'll discuss the sine rule. If you have questions for me, you can send them in through the comment section. Till we meet again in our next class. Take care of yourself and bye.